Hello, my name is Elijah Porter II, and we're going to be doing a little bit of math today. We're focusing on math transformations. I have a problem on the board. Begin by reading that to you. A graphic designer created a logo on 8.5 by 11-inch paper. In order to be placed on a business card, the logo needs to be 1 7/10 inch by 2.5 inches. The question is, what is the scale factor of the dilation? So the first point that we need to be sensitive to in solving this problem is understanding that there are 4 ways to solve this problem. One way is called pictorial, and that means that we will be focused on solving the problem using a picture. Another method or mode is called graphical, which means that we will be solving the problem using a graph on the Cartesian coordinate plane. A third method is called tabular, which means we'll be solving the problem with a table or a chart. And the last way, which is the most common way, is numerically or numerical, which means we'll be focused on solving the problem with numbers and operations. To begin with, I like to always have the students draw a picture to represent exactly what's going on in the problem. So I'm going to draw a rectangle here, and I know it's a rectangle because my sides are not the same dimension or same length. I have one that is 8.5 inches. And I have the other that is 11 inches. Now what's going to happen is we need to produce a new shape, which will still be a rectangle. Its dimensions will be 1 7/10 inch and 2.5 inches. Now, we are coming from the initial shape, which we call the pre-image. And we are producing a secondary shape or secondary image, which we will call the image. And we can see that the pre-image is larger than the image. Now that we have the picture in place, now we can work on numerical. We don't have the coordinates here, so we can't spend time trying to produce a graph. And because we don't have coordinates, we also cannot produce a table. So we're going to be focused on the pictorial and the numerical modes for this particular problem. And it just so happens that that is fine for what we need to do. In order to begin with the numerical, I do need to have reference points. I'm going to label these corners with any letters that I want. I'm going to start with the upper left-hand corner. And in order to label shapes in mathematics, the standard is to start at any corner we desire, but travel either clockwise around the perimeter or counterclockwise around the perimeter. We never travel through the shape. We always travel along the perimeter. So I'm going to start here in the upper left corner with the letter A. I'm then going to call this letter B, then C, then corner D. In like manner, I'll label the image in the same format. I'll start with the letter E in the same location that I began with for the pre-image, upper left corner. I'll start with the letter E here, then letter F, then letter G, and then finally letter H. Now that I have my corners referenced, I can now move into my numerical environment. But before I do that, this is how we write this dynamic in mathematics. The shape here is a rectangle. It's labeled rectangle A, B, C, and D. A, B, C, and D. This shape is similar to, because all we're doing is reducing the sizes of the lengths. So it's similar to, and this symbol here means similar in mathematics, it's similar to rectangle E, F, G, and H. E, F, G, and H. Now that I have a representation of that picture, I can take this symbol or these symbols and transfer them into the numerical space because I have references now. What we have here is something called a side proportionality statement. And what that means is that the sides are related to each other. And our job is to figure out how they are related. The way the side proportionality statement is created is by looking back at this symbolic representation and identifying the first 2 letters of the first shape, which is the pre-image, and compare them or relate them to the first two letters of the second. So we end up here with side AB is proportional. The fraction bar in mathematics can also be read as proportional. So side AB is proportional to side EF. In between each of the fractions, we'll need to use an equal sign. So the first two compared to the first two. We then go to the second and third letters compared to the second and third letters of the image. So we have side BC is proportional to side FG. And there's my equal sign again. And now that we've handled the second and third, now we need to address the third and fourth. So we have side CD is proportional to side GH, third and fourth letters in the secondary shape. And because we have a four-sided shape, we need four fractions here. And we handle that by addressing the first and the last letters, which are AD. So side AD is proportional to side first and last EH. Now, the way this can be imparted with the pictorial, side AB on the pre-image is the top side. Side EF of the image is also the top side. So that identifies the relationship. Corresponding locations. Side AB is the top compared to side EF, which is the top. Then we have side BC, which is the right side, is compared to side FG, which is also the right side. Then we have side CD, which is the bottom, is compared to side GH, which is also the bottom. And lastly, we have side AD, which is the left side, and that's compared to side EH, which is also the left side. So as you can see here, all that we're doing with the side proportionality statement is comparing corresponding sides. Now, because we are dealing with shapes that are similar, this will not equal 1. This ratio will not equal 1. So now that we have our nomenclature, our letters and labels in place, let's take the given information and substitute it inside the side proportionality statement. So side AB, we know it's going to be 8.5 inches because this is a rectangle and opposite sides for the rectangles will always be congruent. So this will be 8.5 inches because the bottom is 8.5 inches. And I'll write this as a decimal. So 8 5/10 is proportional to, now we have side EF, which will be the same as this, which is 1 7/10, equals side BC is opposite this side. This side is 11, so therefore this must be 11. Because again, it is a rectangle and opposite sides are congruent. And then we have side FG. Well, FG is already listed and labeled as 2.5 inches. So 2 5/10 equals. Side CD is here at the bottom and is labeled as 8 5/10 or 8.5 inches. Is proportional to side GH, which is labeled here as 1 7/10. And then we have, lastly, side AD, which is labeled as 11 inches. And that is proportional to side EH, which has to be equivalent to this side, which is labeled as 2 5/10 or 2.5 inches. Now, what we need to do here is determine what these fractions equal to. So we'll plug these into the calculator as 8.5 divided by 1.7. When we do that, we get the number 5. We could also divide this one, which is 11 divided by 2.5. We'll get exactly the same value, which is 5, which incidentally, as we mentioned, does not equal 1. Now, although each of the fractional components are not the same, when you reduce them to simplest terms, they will always equal the same value. If, however, they do not equal the same value, then these shapes are not similar. This value here is called the scale factor. And what this means is, this tells you what is the numerical relationship between this side and this shape and this shape. This tells you that the relationship is 5 times. They're 5 times different. We have to understand, though, the pre-image is larger than the image. Therefore, we can say the pre-image was shrunk 5 times in order to produce the image. Conversely, we can say the image is 1/5 the size of the pre-image. Thank you for your time. And this is the conclusion of what we have here. Also, please note, we did not need to work on the graphical and the tabular. We only used the pictorial and the numerical to solve this problem. as an instructor, the way that you can check, or as a parent, that your student knows exactly or the depth of their understanding, the more modes that they can use to solve any one problem, the greater the depth of understanding. Thank you for your time. Thank you for your time.